So, good morning, everyone, and welcome to this workshop on industrial waste management. I'm Antonella Venza, and I'm the cluster manager of Luce Veneto, an Italian cluster gathering companies working along the supply chain of the smart lighting sector. I'm here with Anna Pellizzari, Executive Director of Materially. She is an expert on material design with more than 25 years of experience. Good morning, Anna Pellizzari. She will deepen today with us the topic of industrial waste management. As usual, she will be very clear, I hope, and with many examples for the companies. And she will be available to deepen all the topics and to answer your questions. So write in the chat if you have any question to submit to Anna Pellizzari. I remember you that this workshop is part of a series of webinars of workshop that Luce Veneto organized from November 2023 to January 2024. And all these workshops have been recorded. So if you need the registration and the slides, you can write an email to info@luceveneto.com. I remember you that also this series of workshops are part of a very structured European project of which Luce Veneto is partner, together with other 6 European projects, European partners. And the goal of the project is to enhance the capabilities of the companies on digitalization and green transition after the COVID pandemic to become more resilient. So as with this call, the partners have organized a very series of to offer to our companies, to our SMEs, and we offer also direct financial support to the companies. We thought to different kind of support, and in particular, we have different calls that we open to support the companies. The first one is on business transformation with the 5,000 euros that we offer to SMEs that require support from a technology provider to improve their capability on business transformation with different kind of topics. A second kind of course on advanced technology activity, so with a bigger support that we can offer to the companies. We can offer also travel check to the companies that want to participate in the hackathon events that we will organize in Romania and Italy. And the fourth one is the talent placement. So we support the companies also inside. So if they want to have an internal research that support the companies on improve their capability on green transition and digitalization, we offer them a voucher of 4,000 euros. I remember you that in this moment we have the talent placement project, the talent placement call open. So all the companies that want to receive this kind of support can submit your proposal until the 6th of February. You can ask your contact points of the SILEO project, national contact points of the partners of the project. And there is also the second call of the business digital transformation projects that is open. So you can submit your proposal until 25 of March. So this is a short presentation of the SILEO project, but if you need more information, you can call Luce Veneto for the lighting sector in Italy and all the other partners of the project. So I like the floor to Anna Pellizzari to start this workshop and enjoy the workshop. Anna, we can hear you. Okay.
Yeah, you're right. Sorry, apologies. I had deactivated the sound not to have your voice coming back into the conversation. So thank you very much. I'm sharing the screen now. Oops. Okay. Okay, so
you see very well. Also the slide.
do you
Yeah.
can you see the screen and hear my voice correctly? If not, just let us know.
Okay.
We are talking about waste today in a perspective of trying to reach one of the European goals, which is getting to zero waste. The presentation is divided. We will talk about waste in three perspectives. We will first start from some basic concepts concerning waste and waste, let's say, terminology. And then we will see some examples of waste management and projects that would manage to treat waste in a more profitable way and also to reuse those types of waste. And then we will see examples of materials that are derived from various types of waste. Since I didn't make a questionnaire this time, but I would like at the end of each chapter maybe to collect some either questions or comments in a more informal way in case you have, of course, something to say or to ask. So let's start with some basic concepts. Okay, which waste, first of all? Clearly, the word waste covers a lot of different things. So we can have post-consumer or industrial waste, which can be defined in case of post-consumer, it is always referred to as waste, while in the case of industrial, let's say, scraps or leftovers or let's say, remains that are not the main product that a company is producing, we can also have byproducts. Of course, today we will concentrate on waste by definition. So what is defined as waste? Waste is any substance or object which the holder discards or has decided or is obliged to discard. So the definition of waste is based on the concept of disposal, which constitutes the necessary and sufficient condition for an object, a good or a material to be classified as waste and therefore codified as waste on the basis of European waste list. Then each country has its own way of codifying these types of waste and with the consequent attribution of responsibilities, of ways of handling these types of waste. But the general framework is that one. Of course, once a residue of whatever sort is classified as waste, its management is subject to specific regulations and authorizations. So it is not that if you have something that is categorized as waste, handling it, to handle it, you must even, by handle, I mean transport, transform it, etc. That must be done by subjects that have specific authorization to transport and treat that specific waste codified with a certain number. all these, let's say, regulatory framework is changing and has been updated in the last 10 years to make waste management more efficient and to introduce principles of circular economy. On the other hand, by byproducts, we mean those production wastes that can be managed as goods instead and not as waste. And of course, they must satisfy some conditions that are established by law, which are, of course, the substance or objects originates from a production process of which it constitutes an integral part and whose primary purpose is not its production. So clearly a byproduct is not the product. So it's something that derives from the main production. Then it is certain that the substance or object will be used during a subsequent production or use process. So there must be some types of destination for that byproduct, either by the manufacturer itself or by third parties, without any further treatment other than normal industrial practice. The substance or object meets all the requirements regarding products and the protection of health and the environment. So clearly it must not be dangerous. Finally, another very important concept is that of end of waste. End of waste is a set of regulations issued by the European Union that allows certain processing wastes to be categorized as byproducts and not as waste, following a specific recovery process. So this is a set of regulations that have been introduced to make possible the reuse of certain wastes in a byproduct perspective. Clearly, what all these regulations are meant to make this waste be compliant with this list of attributes that is typical of byproducts. And this helps, for instance, to transform a waste into a raw material, R material, so a reusable raw material. So basically, if following the end of waste regulations, it means that a material does not become waste, meaning that is not discarded, but can be reintroduced into the production cycle through more simple and more efficient management. This is maybe, how can I say, redundant, but having it is necessary to have these end of waste regulations in order to ensure, on one side, the possibility of reusing these industrial wastes, and on the other hand, to ensure safety for the consumer and for the manufacturers that would use those waste once re-put into the production system. So we will start giving an overview on this big waste area. We will likely call waste in this presentation also some byproducts, okay, just to make it, we would use the word waste not in a legal way, but in a more common way. So what are the infrastructure in place? There are, as we have partly seen in the recycling module, some existing post-consumer recycling chains that somehow also affect the industry. We will see, for instance, how some of these post-consumer recycling chains work as suppliers of raw material for the furniture industry, for instance. So clearly, when to make recycling possible, there must be some supply chains in place. And these supply chains must be capable of course, collecting the product at the end of its life, disassemble it if necessary, recycle the materials, and then reintroduce the materials that are obtained with this process into the production cycle. Since waste management is recognized as a public problem to be managed at a national level, most countries, particularly in Europe, have developed models for establishing those supply chains based on the extended product responsibility principle. In general, let's say worldwide, there are two types of approaches. One is more private-centered, which is based on private meaning individual by companies, for instance, not organized in a collective way. And those are mostly based on services provided by individual companies to third parties, so to other companies, or on internal projects of large companies. So this is a broad set of initiatives to reuse somehow some types of waste and to make the supply chain more circular. We will see some examples. And the other approach instead is more a collective approach, which is typical of the European Union. It is part of the extended producer responsibility systems, and it is based on the creation of consortia, typically of producers. So all producers in a certain sector put together and are legally bound to contribute to the building of this supply chain, and that would be normally done by putting some contribution, some taxes, basically, on their products, which is, of course, then reverted to the consumer. So how does a consortia system work? In Italy, but this is, okay, is similar to other European countries. Basically, we started this consortia system that was, of course, deriving from European directive in 1997. This system assigns consortia the task of ensuring the achievement of global recycling objectives on the national territory and the implementation of management policies, including prevention. Prevention is super important, is one of the areas where consortia, particularly of packaging, work most. Manufacturers, producers registered within the consortia are required to pay a contribution, which is divided among the different consortia to cover management costs, and the participating municipalities that cover the costs deriving from separate waste collection. So this is the scheme, for instance, of the packaging supply chain, which is managed by CONAI in Italy. The packaging consortia in Italy are all under the CONAI system, and they are divided by different materials. So we have Comieco for paper, CIAL for aluminum, Recreate for steel, Corepla for plastic, Rilegno for wood, Coreve for glass, and Biorepack for compostable plastics. Bioplastics, sorry. We will focus just one moment on the Rilegno Consortium, whose task is to organize and guarantee the prevention, recovery, and recycling of wooden packaging throughout Italy. Every year, Rilegno recovers over 63% of the packaging released for consumption and transforms it mainly into panels to make furniture. This is a very efficient supply chain that is particularly strong in Italy, where we have a lot of chipboard manufacturers that rely on this type of packaging waste and also on other type of furniture waste. Rilegno is slowly also try to handle also other types of wood waste and not just packaging, which is mostly pallets. Because there is a high demand of this type of material to produce chipboard. What's interesting is that almost 90% of this wood is then effectively reused in the furniture industry. So it's a good example of a loop that closes. Another short deep dive we make is on electronic waste, which are divided by 5 types. So clearly large appliances like refrigerators, air conditioners, and water heaters. Other large whites like washing machines, dishwasher, ovens, hobs, etc. The difference between R1 and R2 is that R1 has some potentially dangerous fluids for refrigerations, which need a special, let's say, stream. Then we have R3 and R4, which are electronics, basically, so TV and monitors and other small appliances, consumer electronics, lighting fixture, and more, and then light sources like bulbs and other types of light sources. And I have a video here that shows some images of some short introduction of a recycling electronic equipment recycling plant in Sweden, which is managed by Stena Recycling. And that's basically, of course, they recover metal and also plastic. Typically PS, polystyrene, and ABS, and in some cases
plastics from old electronics, creating new valuable resources. All kinds of electronics are treated here, such as hair dryers, microwave ovens, TVs, yeah, you name it. The list is endless. After that, we separate the 2 plastic types, PS and ABS, with electrostatic separation. It's great to take care of our own waste here in Sweden, not having to ship it abroad anymore, and being able to supply our customers with a valuable raw material.
Okay, this is just to see. Then we have batteries, which is also somehow part of the same type of. Clearly, batteries is at the moment more focused on small batteries, but then there are also large batteries for any type of big appliances and also automotive. Textile and mattresses is a very recent and not yet fully established supply chain. According to European directives, textile and mattresses should be the supply chain should be put into place starting from 2023. The first step have been made in Italy with the creation of consortia in 2022. At the moment, there are some, let's say, the first agreements with the municipality are starting taking into place. Of course, it requires some work to find the right spots to collect these types of materials. And there are some also technologies and some companies that are working to develop technologies to somehow recycle these types of materials. We will focus a little bit on textile products, which are one of the most, let's say, complex materials to be recycled. Of course, these mostly involve the fashion industry, but also the furniture industry produces some textile waste from both industrial and also post-consumer. And we will see then how the furniture recycling supply chain is being under discussion. So how does recycling of textile products works? It can, typically there are natural fibers and synthetic fibers. Natural fibers, there are consolidated supply chains for these types of recycling, while synthetic fiber, at the moment, the most realistic prospect is using chemical recycling. Mechanical recycling is the type of recycling that usually happens for natural fibers. It is quite a long and complex type of recycling that would eventually damage somehow the fiber. And so one would have either a lower quality material that would need some natural virgin fiber to be added to ensure the quality, or be used for padding, for instance, for padding materials or non-wovens. There are some, so one of the outcomes can be, in many cases, using recycled fibers to create padding and soft parts for chairs or for sofas. There are several projects that are targeted at developing new technologies to recycle waste from the textile supply chain, and typically in order to help the separation between natural and synthetic fibers. Particularly in furniture, this is a type of combination that is quite common. So normally natural fibers would be used to give some warmth, and while synthetic fibers to provide performance and durability. And this combination makes the materials very complex to recycle. So this is an example of a project that involved several players, particularly Tomra, which is a manufacturer of machines, of sorting machines. And that helps to process pre-consumer waste, so post-industrial scraps out of the manufacturing process directly from manufacturers, and also together with post-consumer waste, so both clothing but also household textiles that contain some non-textile elements like buttons, zippers, or other parts that need to be separated. So this is one, and this is another interesting process that is being developed instead in Australia. This was a startup when we first spotted this technology, and is now instead become a company that with a big production plant that basically helps to work polycotton, so polyester and cotton materials, by creating two different streams, one that would get to rPET, so recycled polyester, and on the other hand, we would have cellulose powder that can be used in industries such as textiles and also pharmaceutical. Also here we have a small video to see the plant. I always love the efforts of video makers to make recycling plants look less disgusting. When you see them for real, they are really horrible. But okay, when it comes to future supply chains, there is discussion ongoing and some talks to establish supply chains for to make the wood industry more circular in terms of finding ways to treat post-consumer products. The discussion is clearly complex because establishing a supply chain like that is very complicated due to the difference, the many types of materials that are used in furniture, from wood, textiles, foams, metal, plastic. There is really a broad family of materials. So there are also discussion around the possibility of better promoting reuse and remanufacturing of certain of furniture, and how to manage in terms of calculating the contribution. That's the most difficult part, this type of supply chain for recycling furniture. And this is, of course, going on between the all furniture associations in Europe and their related ministries locally and also at the European level. And this is for what concerns collective systems. So systems that are there and that are paid by the community and that everyone would use and have benefits from. There are then different, as we said before, private models that are typically based on individual companies, initiatives, and projects that are typically based on take back, so involving the consumer in more direct ways. So the supply chain is not organized by the municipality, but by the main player, which can be a company or a group of companies or some suppliers. We see some examples here. One of the most important players worldwide is TerraCycle. It is an American company that's present in 21 countries and also in Europe. They managed typically in non-European countries in Europe. They are more, of course, more active, or let's say less European countries like Switzerland, Norway, the UK. And it manages the end of life of non-recyclable items through the setting up of national connection and recycling platforms and playing, of course, with different partners. This in the picture, we see an example of a project that they made for Century, which is a manufacturer of children's appliances, children's products, that for some ways are similar in terms of difficulty and use of different materials in the same product to furniture. Basically, what they have done is they have set up a take-back system, which is based either on stores, on Century label stores, or so you can either bring back your product directly to the store, or you can ask for pickup with the mail, basically. And you would give back the material to treatment centers, to the company that would sort them based on their quality. So if they are still reusable, those may also be either given out for charities or to be repaired and resold, or they can be recycled, and there would be different TerraCycle took care of setting up the different companies that would disassemble the material, put the metal with the metal, plastic with plastic, fabric with fabric, and foam with foam. So and then each of these streams would be recycled separately. Another examples that you would probably know very well is that of Nespresso, which has established its own supply chain with the take back of the capsules when they introduced this type of format for their coffee machines. In Italy, this is done in collaboration with CIAL, which is the consortium for the recycling of aluminum, and in other countries with other local entities. This is also done because this type of aluminum has some layer, maybe in silicon. I'm not sure 100%, but I think it's either silicon or PE to, of course, keep aluminum separated from coffee. And that requires some special type of recycling process. Of course, in this case, you need to have your own store to set up the collection. Other areas where there are projects ongoing is that of, or in general, all the area of disposables. This is an interesting project that takes care of disposables in the medical industry, and particularly of those devices, single-use devices to shot insulin for the people with diabetes. This project was carried on by Novo Nordisk, UK, so in UK, and it set up a collection system in pharmacies that was managed by Novo Nordisk, and the material, the products were taken back and then recycled, and the resulting material was used to make some chairs that were used in some offices. This is, of course, an experimental project at the moment, but is like a sort of pilot project to set up a potential supply chain for this kind of products and provide also raw materials for other industries. Another interesting example is this one that was launched by Auping. They are a Dutch company that produces mattresses. In 2011, Auping launched the first take-back system. They basically launched a program to become fully circular. They tried to act on both directions. So at the beginnings, by designing a mattress that could be recycled at the end of, more easily recycled at the end of life, and then also to taking care of end of life, by launching this take back program, which resulted more difficult to handle than they expected. But still, the idea is to, on one side, design a recyclable mattress, which in this case is a mattress that uses less foam and also a particular type of recyclable foam, and then sleeved springs that can be easily separable, and the springs can be reused, some of them. So with an old mattress, some of those, some springs may be defective, may be damaged, but in most cases springs have a very, very long life and can be reused in other mattresses, and the fabric and non-wovens actually can be recycled. And then after that, they also launched this servitization system. So renting the mattress instead of selling it. The project was later taken on from another company, which is El Buco, a Dutch company that is specializing in this type of long-time rentals for typically communities, and also on recycling. They are like one of these consortia for recycling. So basically the idea is starting with a recyclable mattress and then ending up circularizing the product and taking care of it from since its birth to its the very end. Okay, do you have some questions or something that I would like to understand what type of waste you take care of, for instance, in your production, and whether you have some specific issues with waste management. Okay, if there is no questions, we can go on with other examples. Do you need to restart the recording, or is it?
No, it's okay.
Okay, so I can go on. Okay. Towards zero waste, there are various ways.
Sorry, Gianmarco,
It's okay.
Piacenza.
It's okay.
Okay.
Hello.
Hello?
It's good. It's okay.
Okay.
Okay. Do you have any question, Gianmarco?
The lesson is interesting.
Okay, perfect.
Thank you. Okay, so we when it comes to managing waste, with the aim of reducing, aiming at zero waste, clearly we have companies have various ways to manage their waste. The typical, let's say, way would be paid disposal. So a lot of waste still represents a cost for companies because it has to be collected and disposed of for a fee. So clearly it is it is the first interest of a company to trying to reduce that type of waste, finding ways to reuse it, to turning it into some type of value. So the second step would be identifying specialized operators that would take care of that type of waste and collecting it and taking it away either for free or because or with a small amount of money. And they would also, in many cases, also set up some pre-recycling unit at the companies themselves in order to, for instance, reduce the volume of the waste, and also clearly reduce the cost. But clearly everyone aims at turning its waste into value. And this can be done by reducing waste in the first place. So trying to either reuse one's waste internally or to clearly reducing it by design. This is not the topic of this lesson, but clearly design plays a very important role in all this conversation that we are having. And I guess that you also had some perspective on that topic as well. So reusing waste internally or making also projects of industrial symbiosis, which means that one's waste becomes someone else's resource. And we will see some example. No, this is not plastic collection initiative. Sorry, I will change the title. It is clearly more efficient use of wood. This is a project, a school project. So it was, again, going back to the role of design. This was a project that carried on by a British architecture studio, Studio Bark. Bark means bark. And that worked with students from the University of East London to reason on the most efficient way to use wood logs to reduce the waste. So they somehow recovered some old traditional building techniques that would use round sections rather than rectangular in this way, so that also smaller trees could be used in order to reduce also the quantity of wood that's cut off, and also to use also logs and trunks that are less valuable in a way because they are or either younger or smaller or less valuable. Another example is this type of veneer that's obtained from the company's cutoffs. The name of the collection is Biodiversity because it uses different pieces from, again, the cutoffs and the, let's say, spare parts, the remains of other processes. That are glued together. Clearly, you probably know it. It is an Italian company that works with that produces engineered wood, so veneers, and they mostly work with the natural dyed woods. And of course, in the cuts, they have many parts that are too small to make a large surface. So they would reuse those parts and glue them together to create various designs in order to reduce their own waste. Another project that was launched like 5 years ago, more or less, this was launched by Autogrill. Their idea was that of reusing the food waste. Of course, they have a super large amount of food waste in their cafeterias all throughout Italy, but not only. They identified 3 main streams of waste. One is orange peel from orange juice they make on site, coffee waste, and PET bottles. PET bottles have, let's say, very efficient recycling streams, as we have seen before, and also in the recycling module. So it's that's taken care of by the common system, by the consortium system. While instead both orange peels and coffee would become compost in a way. So they were wondering whether they could use this source of raw material, which is continuous. So they have a continuous and stable production of this type of waste to create some material. So they worked in 2 different streams. One was that of the orange, with the project called Was Orange, and the one with coffee with another project that's called Was Coffee. In the case of Was Orange, they developed this experimental material, which then became a real material that's being used by Krill Design. Krill Design is it was a small, but now they are quite well established design studio in Milan. They had originally started working, they work with 3D printing almost exclusively. Their founding idea was that of moving only not reducing the export of products by exporting just the file and having people printing their own stuff at home. And now instead they sort of diverted their expertise into the development of new materials, new bio-based materials. They work in collaboration with MAIP, who is a quite famous compounder. And they have developed several different bio compounds using food waste, the orange peel from Autogrill, and also another project with coffee with the Milan municipality. And in the end, what the result is like a filament for 3D printing that is used internally by Autogrill to create these containers for sugar or other accessories, and became a filament to create lamps and other accessories by Krill Design. The coffee project was instead used coffee to make boards. With some difficulties, but in the project was very interesting, let's say theoretically. As I said before, okay, this was what we have seen here, examples of companies reducing waste, okay? So reducing their own, sort of making projects to reuse their own scraps. In this case, this is an example instead of collection and the recovery of industrial waste, typically foams, which is non-recyclable internally. So it is not foam, is a thermoset, so it cannot be recycled by the company in its own production process. But there are some companies that would collect those foams, grind it, and make other products. These companies would install some machinery at the manufacturers, at the producer production plant, to partially grind and reduce the weight of these materials, and then they would take it back to their production plant, grind it, and create. This is an example backing for sports floorings and other types of materials that are basically foam aggregates. This is instead a project of industrial symbiosis in the textile sector. We have seen it maybe also in the first module. In this perspective, this is we have seen the project by Quadrat in the first module, which is similar. The difference is that Quadrat uses its own scraps, its own textile waste, and they have created a sort of product line of its own, that are these boards made of these recycled fibers with a binder that creates these boards for architectural or furniture or whatever type of applications, while Nazena works with various suppliers. So this is still a startup, and they are developing various types of potential surfaces, more or less rigid, also trying to use, for instance, these types of fibers to make insulating boards, so semi-hard with, say, low density boards with insulating, both sound and thermal insulating properties. You will see that most of these materials are either blue or white, and this is because the suppliers come from the denim manufacturing. The company is in Veneto, where there are several denim manufacturers, and also from pure cotton, undyed cotton, which is the white one, and that can also be used for packaging. It is food grade because it's pure, not dyed, and doesn't have any migration issues. Clearly, the denim industry is one of the preferred type of industry to provide scraps for this kind of materials. There are a lot of different companies and startups that use these types of scraps to make boards and other types of surfaces, because it is they manage to provide a consistent and continuous type of waste, which is one of the main challenges for the reuse of waste. Waste must be always the same, with the same quality and with the same quantity, and this is not easy, let's say, to achieve. And remaining in the textile industry, a good example of industrial symbiosis is Off the Grain by Cotonificio Albini and Risogallo. The Risogallo, it is an Italian company that works that's based in Piedmont. That's the area of rice. And in the various types of rice they treat, they also have some so-called black rice, riso venere, which releases these very deep red and sort of wine color wastewater. That's the result of the processing of this type of rice, the washing and the pre-cooking of this type of rice. And so they realized that they had this type of byproduct. This is actually a byproduct, which was, again, consistent in the quantity, consistent in the quality, with some potential use. So they started contacting various textile manufacturers in the areas, and in the end they ended up in Bergamo, where Cotonificio Albini is based, and they developed together a technology to transform this wastewater into a dyeing technique. Clearly, it's not just the color that's needed. There is also the finishing process and the fixation of the dye, and also to make it consistent and stable in terms of color, so UV resistant, etc. And starting from this collaboration, the Albini developed a whole collection of cotton textiles with the various shades of this brownish red or reddish brown, which is very characteristic, and it is totally natural in terms of color. So there are also some irregularities, which also make the color particularly interesting. Clearly, this helps reducing the use of water, because there is already the medium, the pigment is already in an existing medium, so the same water is used as a dye. Other interesting projects to use in particularly small amounts of scraps is upcycling. Okay, upcycling, it's one of those, let's say, design approaches that has been, popular since the 70s, I would say. Became also, had some sort of revamp in early 20s, and now is being used by some companies, particularly to manage small quantities of scraps. There are several companies that are born and that would propose collaborative projects to companies. This is an example. It's a Zero Lab. They work mostly in the leatherware industry because they are based in Tuscany. These types of companies would normally propose a double approach. So on one hand, either development of individual small projects to create objects out of small quantities of scraps or of occasional types of scraps, typically sample sets or leftovers in the stocks, those types of things, or instead projects to continuously use scraps and transform them into objects. So for instance, if you are a company that manufacture big products like sofas or chairs or etc., you would have scraps that are too small to be reused in your industry, but maybe big enough to be used in other industries, like to create gadgets or belts or wallets or bags, etc. Clearly, the design intervention helps to adapt the original material to the new use. And what's interesting in particular of Zero Lab is that they also have established a small matchmaking platform on their website where companies that produce some, or they have some single, I don't know, a single leather, for instance, they are specializing in leather, would put this leather in their marketplace, and that can be, instead of throwing it away, because if maybe it was like a sample that they had developed to check some color, and maybe it was not the right color. So instead of throwing it away, they would put it in this marketplace, and that can be used also by common people to make any type of leatherware at home, or by designers, or etc. With of course a much cheaper price, because that would save the money to the industry not to dispose this type of waste, and that would save money by the buyer that would buy a cheaper material. So it's a sort of win-win situation. So there are many projects like this, and many supply chains in place, particularly. We have seen in maybe module 2 or 1, this composite material by GIS recycling, we would see it here on the side, on the other side, so on the side from the waste. So this is the waste they start from, which is industrial waste, non-cured, or also cured in some cases, composite materials or scraps of TPU or TPE that would be recycled into this material that can be used as like a solid surface. Okay, we are now approaching the third part that would give an overview of different materials from waste. Do you have any question, any comment, curiosity? Okay. So I'm proceeding. It was just to have a small break into 2 hours straight of conversation. Maybe it's difficult for you to follow all these 2 hours straight. So just to make a small break with some. Okay, so I will make a question and I would ask you to answer in the chat. Is that possible? Is that technically possible?
Can you repeat, Anna? Sorry.
I said, if I would make a question and I would ask the audience to answer in the chat. Is that technically possible?
Yes.
Yes, yes.
Okay, so I would like to ask you which type of waste your company deals with. Okay, so here we have.
I remember getting these two
Okay.
charts, the answers.
Okay, we are getting some answers. We are getting plastic waste, of course. Plastic, yeah, and office waste is also something that's there are okay in a reduction perspective. Office waste is very varied, can go from let's say paper, which is very broadly recycled, but there are also cups, for instance, and also other types of toners, for instance. Those for all those materials, there are dedicated supply chains that would take care of these waste in the proper way. Typically, I mean, I guess that in all Europe, these should be into place. Wiring, wiring is electronic waste, to my understanding. Urban waste, urban, okay, and then back, well, yeah, so in industrial terms, I see plastic here mostly, and then wiring meaning cables. See, yeah, okay, electronic waste, yes, yeah. Okay, so yeah, so Nani is working with wood very much, but okay, so we are okay. I'm giving just an overview of materials coming from waste, and here we will consider not waste that has some proper recycling supply chain, because that we have seen already in module 2, where we were discussing, we sort of faced the topic of recycled materials. In this specific chapter, we will take a look at those materials that have not very well established supply chain for recycling, and that are sort of ideas and new ways of to try to reduce the quantity and the amount of waste, or to exploit some specific types of waste in order to create other materials. Generally speaking, in all this module, we tried to collect as many examples as possible to stay focused on furniture and lighting products, but we would also like, for this module only, to open the mind a little bit, to go more into some areas that is more like a suggestion of a method rather than giving examples of what to do in the furniture and lighting system. So, which type of waste are we talking about here? So we will talk about agricultural waste. This is a source of fibers, typically that can be, or even sheets of various types of materials that can be transformed into other materials. Then we have waste from the food industry. So industrial waste in a way, but or byproducts, like for instance the examples we have seen of Risogallo and Albini. So in that case we had a waste from the food industry that can be used to do something else. Waste from industrial processes, so again materials that cannot be reintroduced into the original production cycle, that can be classifiable either as waste or byproducts, and if they, of course, if they are reused, they went through the end of waste and are therefore become byproducts. Then we have mixed waste, some examples of technologies to start from mixed waste, urban waste, not relying on separate collection like it is done particularly in Italy, but generally speaking in Europe. Then residues from waste treatment processes. So once you have treated some type of waste, you get other waste. Partly, of course, you would recover some interesting and useful raw material, and then get another type of waste, so-called. For instance, we are talking about residues resulting from wastewater purification, incineration, or other waste treatment processes. And finally, we have materials dispersed in the environment, that are materials that are directly recovered from the environment. So litter, basically. So let's start from agricultural waste. The world of agriculture is seen as a new sector, new interesting sector from which to source new materials or new raw materials for both interiors, architecture, packaging, textiles, furniture also, etc. With a view to recover these typically fibers and transform them into raw materials for durable or disposable applications. So the idea here, all the idea behind using this type of waste is not that it's dangerous waste. In some cases it is, but in other cases, it's just a way of reducing the use of other raw materials and using something that would be discarded, which is a pity in a way, no? So various scraps produced by different, often local plantations. Also, in many cases, they possess intrinsic characteristics that make them suitable, for instance, for architecture applications, for interiors, like, for instance, water repellency or some fire retardancy. And while usually maintaining breathability, for instance, because they would be natural materials, bio-based, and low or zero emissions of volatile organic components. We have seen in one of the previous models this set of materials from rice husks. I put it as an example, so I will go very quickly on it. Then we have other types of fiber-based boards. These are coconut fiber-based panels that are made of the coconut husks, which is a byproduct of coconut cultivation for food purposes. Of course, this represents some problem because there are already traditional uses for these types of fibers, that those are used typically to make ropes or rugs, so some textile products, mats, those types of things. But the quantity that's generated by these types of cultivation is huge compared to the quantity that these industries can actually absorb. So there have been several startups that tried to develop materials, boards, typically out of this type of fiber. Some of them failed. This one, which is the name is Cocoa Board. I don't remember the name of the company. They developed an interesting combination of coconut fiber and lignin, which is used as a binder. What's interesting is that the coconut fiber is not easily biodegradable. So of course it is biodegradable because it is a natural material, but the fiber is very resistant. And in fact, it is used on rugs. So it would not degrade very easily. It has also some fire retardancy properties intrinsically. And also what would happen is that farmers would burn those waste on site, which is a very smoky type of material because it contains some oils, which would be extremely polluting, particularly locally. And so recovering this type of waste has a double advantage, solving the problem of this type of waste and reusing it in a more profitable way for long-lasting applications. Other types of plants that come from that are grown for food, which is banana, they are also used as a source of fibers, with which making textiles. Also banana leaves can become, not banana leaves, sorry, banana trunks can become a veneer. Some companies in the Central America would propose this banana veneer. And this is also another way of reusing all the plant, so not just the fruit and then discarding everything. These are particularly plants that, particularly banana, that would not the same plant doesn't produce more and more bananas. It would die and then they have a very fast cycle. So it's not like an apple tree that would produce apples for like 20 years. The banana cycle is very fast, so the production of fibers is very intensive. Then, of course, all these agricultural products would be transformed by the food industry and produce waste also in this step. The downstream of agricultural production, the agri-food chains include several processing steps that can generate various types of waste. There are many projects to recover and reuse this type of waste to create a variety of raw materials. Of course, they are bio-based. By using these materials, we would also prolong, let's say, the life of CO2 as carbon stock in materials. We will see all. So this is also one of the advantages of using bio-based materials from these types of industry, because the carbon would remain in stock and would not be released back to the atmosphere. This is an example of Italian company that's Caviro Group that makes wine. It's a consortium of different wine manufacturers, and they have developed a circularity plan to use all the parts of their supply chain, of their production, starting from grapes to make wine, and then all the other byproducts, which can be either so-called noble byproducts like distillery products, liquors, etc. These process would create other plant-based, other vegetal waste, which can be turned into energy. So it would basically be incinerated in a waste to energy process, which is bio-based, by the way, and in part become natural fertilizers to be reused by the farmers. The food industry, another byproduct of the food industry that turned out to be an interesting coating is this bioresin. The name is Toma Paint, is a biolacquer that's that has been developed starting from tomato peel. Tomato peel has some natural and intrinsic oil and water repellent properties that's given by this component that's called cutin. This process would extract this cutin from the tomato peel that's processed to make tomato sauce. And the result, at the end of the process, this component would become part of a coating for metal applications. It is bio-based and therefore totally food compatible. So it was originally thought to be reused into tomato cans as an internal liner, internal coating to protect the steel from the sauce. So it is another example of circularity. At the moment, and other developments of this type of coating is being applied for paper coating as well. And there are some also opportunities to use it for standard paintings to provide some oil and water repellency. The problem is that it is brown. Of course, it comes from tomato peel, so clearly the applications could be in areas where having something brown is not a problem. Other examples of projects that would use agricultural, agro-industry waste is this project by, well, this is by Favini, but also other companies have developed something similar that would use some agricultural, agro-industry waste from various industries, from corn, citrus, kiwi, olive, pits, almond shells or hazelnuts, coffee grounds from the toasters, the coffee industry, to provide colors. Basically, it's added in up to 15%, but with the, let's say, average 8 to 10%, and these would provide also some color to the paper and create a collection of decorative papers. This instead is a bioplastic that has been developed in Turkey using, it's a biocompound actually, because it contains discarded olive pits. It is partly obtained by secondary oils from the oil industry, and in part from the fiber of the olive pits. This is a type of material that has been developed within a funded project by a Turkish manufacturer of appliances in collaboration with an industry that produces oil. Clearly, there is the pressing of oil, which would release the first quality oil, then second and third, and then at the end you would have a type of oil that's not edible anymore, and it would be used as additive or as base to create some polymers, like in this case. And the fiber of the pit can also add some structure to the biopolymer. Clearly, in all these examples, you would see one main problem, which is the color. So we would always have these types of waste-like color. So there is poor control over color. In the case of Favini, clearly they probably tuned it and also managed to exploit the chromatic aspects, chromatic characteristics of this waste to make some collection of natural colors. Otherwise, we would have this, or we would have this, which is brown, or also the coconut board would be that color, and that's it. So unless you cover it with the decorative papers, you would have a color that's that one. Then there is a broad family of leatherettes using waste from various types of industry. This is one of the most famous, which is apple skin, and that comes from waste from the apple chain. But there is also the one with orange we have seen in in one of the previous modules. Another Turkish company makes it with the waste from tea, etc. Basically, in this case, what happens is that the agro-industry waste is dried, ground, and added as a filler, as a component of the polymeric part that's spread on the surface. In some cases, we have instead a sheet which is extruded. That would depend on the type of technology that the company uses, but in most cases, it's a composite material where the waste part is ground and used as a filler for some polymeric binder. It can have a backing or not, but all these types of materials are basically used to reduce the oil-based percentage in these types of artificial leathers. Then we have some other types of leatherettes. That's in this case this is still experimental material that makes use of animal waste. So this is a byproduct of the meat industry. So there are some parts, nothing is wasted from the meat industry before consumption. Post supermarket, that's a very painful subject, but before, normally everything would be used in a way or another. So there would be the meat, and then from the meat there is the leather industry that would also clean the leather, the hide, and a lot of other gelatin, jelly, protein-based material would be discarded in that process. And this is a material that would use that type of waste to create a leather-like material, which is actually animal, but is is a way of nobilitating somehow, of making more precious a material with very, very low value. Also, the process is more, let's say, it's quite sustainable, doesn't require always going to working in the area, remaining in the area of animal byproducts. There are some yarns produced from casein, which is the protein of milk. Also, the milk industry has a lot of waste, and those waste can be used to extract these proteins that can then be transformed into polymers to typically make yarn. There are a couple of companies, one in Germany and one in Italy, that produces this type of yarns that are, by the way, 100% bio-based and compostable in case. Then we have waste from industrial processes, various types. We have seen some also in the previous presentations. In this case, we mean non-recyclable post-industrial waste that can be classified as waste or byproduct, and that cannot be returned to the original production cycle. They are often byproduct of various production processes. As we have seen before, they are often a cost for companies because they require specific disposal. Some examples of materials obtained from these wastes are, okay, this is an example of product actually. It is an interesting case study because it is made of 90% recycled materials. These post-industrial, in most cases, coming from waste from the Portuguese textile industry. Cotton fabrics also recycled to make new yarns, and the sole is made from at least 70% rubber waste, which is also quite visible. Of course, a certain percentage of virgin rubber is necessary to bind all this waste together and also to ensure some durability. And then all other parts are also sustainably sourced. So we are talking about organic cotton for stitching, embroidery, and woven label. Also, the paper industry can contain and recover the so-called cotton linters that are the byproducts of the textile industry. Besides, they also improve the quality of some papers. So in some cases, it is also an efficient way of using these types of waste, because they have a longer fiber than cellulose, and so for some types of paper applications they are even better than cellulose. This is an example of decorative material that it's not, it's a sort of rare material that was obtained from the multiple layers of paint deposits of different colors recovered from the automotive paint stations. Now there are other ways of painting automobiles, so painting cars. So this type of material cannot be produced anymore, but it was an existing way, an interesting way of how creativity can transform a waste into a material to create. In this case, it was pieces of jewelry, rings, bracelets, etc. This is a material, a biocomposite, meaning that it is composite with some bio-based content containing various industrial wastes. It belongs to those family of one-of-a-kind composite materials that have their own proprietary technology and recipe. It is, according to the company, composed entirely of industrial byproducts, also with some vegetable fiber filler, up to 60%. So it's a mix of industry and agro-industry. And then a biocomposite matrix that's based on proteins, minerals, and oils, and does not contain PLA or PHB. It is a thermoplastic material in a way, so it can be recycled by the companies that use it. At the moment, the applications include, they have made some experiments with coat hangers, consumer electronics, loudspeaker housings. These are some casings for electronic parts, because they are also, they have some insulating properties which make them suitable for electronic applications. Ceramics also is a sector where it's basically like thermoset. They are very difficult to recycle, because once they are fired, there is no way to bring the process back. So normally there would be waste from the industry that can be either reused internally or used by in design projects, like in this case. This is a material that has been patented by a startup, and it is made of recycled byproducts of local ceramic companies that are pulverized and mixed with virgin clay and reworked by hand. So there is a part of unfired waste, part of fired waste, and part of virgin of new clay, and everything is mixed together. This is also another project to reuse scraps from the marble industry. These are surfaces and also objects, but mostly surfaces. They work mostly on surfaces, rejoining together pieces of the recombination of marble scraps. Clearly, each surface is different, so there is no way to obtain the same surface, the same design twice, or at least there could be, but it's very complicated. And that's also the interesting feature of this material, to have always variations. Clearly, there are some preset designs that, and one could also sort of combine its own design to make to combine different types of marbles that they may have in stock in order to create personalized designs. Always from the stone industry, this is a material that was originally proposed by a startup with the name of Marmor. And it is now, I think, produced, industrially produced by Limonta, maybe. And it contains some component from the marble industry. So it is basically calcium carbonate, which also gives the surface a very silky and smooth hand, very pleasant. And also the different types of color combinations are derived from the type of powder, or the type of dust, of stone dust, that has been used since the beginning. Then we have non-recyclable waste. Here we go very quickly. Sorry, mixed waste. These are waste that require some specific technologies. So like, for instance, shoes. Okay, you can just grind them and put them together. There is no way you can separate. And so, as we have seen before with the textile industry machinery, there are some here. All the work is to design and to build machineries that are able to process these mixed waste, to sort them somewhere. In this specific case, we talk about textile foam mixed products. And this machinery is able to grind and card and reassemble these types of very heterogeneous materials that are composed by fibers, by foams, by plastic. And so it is able to work this material all together. Here we have a couple of examples from countries where the separate collection is not that common. This is an Indian technology, and this is Israeli technology. So basically here these are sorting machines, basically, that are designed to separate everything. To start from mixed waste, including also food, which today for us it's like a sort of crime to put together food waste together with other waste. But there are many countries that have chosen a different approach. So taking care, so the common system would take care also of the sorting. And in this case, we have a type of process that would separate the materials and then obtain, in the end, after washing and sorting, the proper material, something that can be pressed and laminated to create boards. This is instead another process that's developed by an Israeli company, and that converts household solid waste, also food waste, into recyclable and bio-based thermoplastics. So they would combine food waste. They would start from, let's say, heterogeneous waste, which would be ground all together and then sorted into different streams with this specific machinery. And also the food part, the bio-based part, would be converted into polymers. Some polymeric part can be, some parts that can work to be transformed into polymer are extracted from this food waste and combined with the other plastic that's instead part of the recycling stream, so PE, PP, other polyolefins. And then it would become a granule that can be injection molded and transformed into typically, let's say, non very high performance products. So containers, boxes, hangers, vases, that type of products that do not require specific performances, mechanical performances or compression, resistance, etc. This is another example of a mixed material that is basically coffee cups laminated with PE. And in this case, the company would transform, instead of separating how it normally happens, it currently happens like this, that these plastic laminated paper cups would be recycled in the paper stream with a recovery of the cellulose part, which is separated from the PE that goes to a different stream. In this case, everything is worked together and becomes a sort of granule to be injection or compression molded to make objects, like in this case, this tray. So there is no need to separate the material. It's somewhat a more efficient process. Then I would go very quickly into this. Residues from treatment processes. Here we go into very, very dirty materials because they are residues resulting from wastewater purification, incineration, or other waste treatment processes. So bricks from waste. These are basically bricks made of biosolids. Normally, biosolids in most cases are either landfilled or incinerated because they have a high thermal potential in a way. So and also they are bio-based, so it somehow makes sense to incinerate. This is a project. There are several projects of this type to reuse these types of biosolids. This is a project at the University of Melbourne to try to develop bricks out of these biosolids, and they have some interesting properties like thermal insulation, and also they act as carbon stock. So basically, they are like a carbon sink system, where the carbon from the plant and then the animal and then us is encapsulated and can remain stored in that brick for a long time. These are other types of bricks that are instead coming from dredging sediments. So in this case, it's like mud plus other canal residues that are basically the waste of the cleaning of Dutch canals. And these types of muddy substance is used to make bricks to pave streets in Amsterdam. No, Delft, sorry. And finally, we have materials dispersed in the environment. These are materials this is basically materials that are already there and that are recovered somehow to to make other types of object. One example is the recovery of wood. So it can be either wood from that has died, let's say fallen trees that died spontaneously. This is an example of a flooring material that comes from timber from these types of recovered trees. These do not come from cutting trees, but rather from recovering trees that have died by themselves in due time before they rot. In this case, the advantage is double. So using a material, a wood that doesn't require cutting of trees, and also cleaning the forest, because otherwise those woods would remain there and rot, and also besides releasing carbon back to the atmosphere, it would also create somehow make the ecosystem, the forestry ecosystem less healthy. Then another very famous example is the briccole from Venice Lagoon. This needs to be replaced over time, and so these types of woods have been profitably reused by various companies as veneers for flooring, tables, etc. It's a way of reusing this wood. And then we have plastics from the oceans, which is, as we have seen in one of the module 1, most plastics produced in the last 50 years have been disposed of in landfills, often open air, or abandoned in the environment in an unregulated manner. So through the work of air and water, many plastic products, which tend to be lightweight, have been transported to the oceans, creating the floating waste agglomerations that are known with the very fancy names such as Great Garbage Patch or Trash Vortex, etc. This is a map of clearly one should not think of these patches as real patches. The distance between these are enormous areas clearly, and these are areas where higher concentrations of ocean plastic has been registered. Otherwise, you would not even see one piece from another. It's not an area where you would just go and rake them like leaves in your garden. It's super big area. But clearly these types of plastic are becoming more and more of a problem because they are entering the food chain, and they are polluting, especially in small seas like the Mediterranean, etc. So plastic recovered from the environment, there are several initiatives typically carried out by associations in cooperation with local realities. Many of them are active in the Far East, where this problem is much, much bigger. Almost the best known initiatives are partly for the oceans, or the Ocean Cleanup Initiative and the Ocean Recovery Alliance, Waste Free Oceans, which is also operating in Europe. Of course, in Italy, legislation has only recently been introduced to allow fishermen to bring back ashore plastic waste. Otherwise, they would be compelled to throw them back to the sea. So we see one of these. Typically, these organizations would then create small gadgets that they would sell to support themselves and to support these initiatives. It makes much more sense to collect these waste from shores, from beaches, rather than go and pick them up from the oceans. These types of materials would be typically used in yarns for textiles, which is the applications that has the lower technical requirements. So it would be either from PET, so polyester, or from nylon, typically nylon nets for fishing. Or to make also 3D printing filaments. This is also made from nylon from fishing nets. And then we have litter, and this is the last chapter. We will have then a small addition. This litter is more of a social problem rather than a material problem. But these are some examples of projects to somehow collect some very common litter, like in this case chewing gum. The project, of course, was more concentrated in the collection of chewing gum, because when it goes on the floor, it would create those horrible black patches that would then need to be scratched away by taking long time and also a lot of effort. So this was a project and also to sensitize towards this problem. And then the rubber that's contained, natural rubber that's containing chewing gum, would be recycled to in other type of rubber, with a small percentage, of course, to create accessories to promote this project. Then this is another project that would create yarns, for knitting yarns from plastic litter, from dispersed plastic. So again, this is a research project that aims at recovering polyethylene. This was an African project where there is still a lot of flying polyethylene bags around. And then we have cigarette butts. Also, this is also an area where there are some actions at directive levels. So, for instance, this startup, Resig, they have developed a technology to recycle cellulose acetate from the filters, and they also have worked to establish a collection supply chain, starting from the assignment of a specific waste code for this specific type of waste, in order for them to be able to reuse it. Other companies, other projects would try to develop different materials out of acetate cellulose from padding materials, because it would basically become like a fiber, up to fillers, cellulosic fillers for extruded plastic parts or asphalt, cement, those types of application where there is no bias concerning the origin of the raw material. This I would skip. You can take a look at it by yourself. There are some experimental and artistic projects using waste. I had put it just in case there was some hole in the presentation, but it's 11, and I think we've seen a lot of things today. That's more than enough. So if you have some questions, of course, I'm available in answering them. So today we moved a little bit away from furniture.
Too many things. I don't know if someone wants to write in the chat or ask the Yeah, I don't see any questions, so I would like to thank you, Anna, for your experience, for your availability, and for sure it was a pleasure to have you as a speaker in our workshops. So thank you. I give you the contacts if you want the companies that participate in the workshops, or who be interested in also to have continue the collaboration with the participants.
Okay, I have a question about the recycling of polylactic
I can
acid,
help you.
also known as PLA. We are developing a piece of furniture which is made of PLA, and we are trying to understand what will be the end of life of this product. PLA is a compostable plastic and can be recycled with the food waste stream, but I think no. Yes, I understand. Okay. First of all, I guess that the PLA that you are using is not, I don't know whether it is 100% PLA or if it is PLA with something else. Normally for durable application, PLA is combined with other polymers or with fillers to ensure compression strength and other kind of mechanical properties. So that would also be a problem. Recycling PLA at the moment, PLA is mostly used for packaging application. In some countries in Belgium, they are developing recycling plants for PLA packaging. The problem with the recycling is that it should be based on an established, as we have seen before, as an established supply chains with its own rules. So even if there is recycling supply chain in place to recycle PLA for packaging, that would work only for packaging, because it would be financed by the taxes for the extended product responsibility of the packaging industry. So it wouldn't be able to recycle a PLA chair or a PLA pen or whatever. So that's one of the problems of the current way of recycling materials. So to answer your question in short, in Italy, to my understanding, PLA is composted, and it's not recycled. I remember seeing something in Belgium, a recycling plant, either in construction or design or planning, or even already in place to recycle PLA packaging, which is the area where it makes more sense, right? So in the case of a PLA chair, which again, I assume it is also made with a mix of also other materials, I guess that the main sense is to reduce the overall carbon footprint compares with using oil-based plastic. So I wouldn't consider that a choice for end of life. It's rather a choice for carbon footprint. I assume that PLA has a lower carbon footprint than ABS, for instance. So that's the reason why it makes sense to make a PLA or PLA compound chair. I hope I answered your question. Okay, so if you have no other questions, I thank you very much for following this course and not falling asleep. You've been very brave, and hope to have the chance to collaborate in some way with the Luce in Veneto or who any of you other companies participating into this project.
So, thank you, Anna.
Thank you.
Bye, and have a nice week.
Bye, thank
Same to you.
Bye.
Ciao.
Bye.